In this lesson, you are going to learn oops concepts in Java and some other important features of Java. Upon knowing these 2 points, you will understand how powerful the Java programming language is. In this lesson, I will be using 2 terms called as class and object. I'll just formally define what is class and what is object as part of this lesson. And more details about classes and objects, I mean how to create class and what is the actual importance of class, how to create an object, what is the actual importance of an object. Entire details including examples and programs that we will be covering in the upcoming lessons. As part of this lesson, I'll just formally define what is class and what is object, because so as to make you understand the features of Java, at some point I'll be using these terms called as class and object. That's why I need to formally define what is class and what is object. Alright, let's look at the formal definition of class. Class is a combination of data and operation. Operation is more formally called as a function. A class is a combination of data variables and member function. An object is an instance of a class. In a programming languages like Java, you can create any number of classes. For each class, you can create any number of objects. This much is enough for you to understand the features of Java. The following are the 4 important oops concepts: abstraction, encapsulation, inheritance, polymorphism. We will see each feature with example. It is very important for you to understand each feature of these oops concepts. Then only you will really start loving this programming language. We'll start with abstraction. Imagine the usage of micro oven in your kitchen. If you want to use a micro oven, what we do generally in the kitchen, we'll just switch on the power, open the door, place some food, set the time, set the temperature, that's all. Relax for some time, and afterwards automatically your micro oven will switches off the power and indicate some sound to you. You will come to that particular micro oven, you will get the food and served hot. This operation is usually we do in our kitchen. So as to use micro oven, nothing more we need to know about micro oven. But all the internal implementation of micro oven, like in a micro oven, there is internally a chip, an electronic chip called as microcontroller, which has an inbuilt memory, which is used for electronic programming. We are setting the time and the temperature, and there should be an electronic device inside. Some programming is done. The details of that programming and the details of hardware that is used inside this micro oven is not that important for the customer who is using this micro oven. It means that abstraction feature is already there for this micro oven. Like micro oven, there are plenty of real-time examples for us. In order to drive a car, you need to know how to use steering, how to apply gears, how to use the acceleration, clutch, etc. things, and switching on the air conditioning and switching off. That's all. This is good enough. And you need not to know more details about working principle of engine. Really, I never come across the working principle of engine, but I know how to drive a car. In the same way, you might be driving a 2-wheeler or a 4-wheeler, and you need to know only how to drive the 2-wheeler or 4-wheeler, but it's not that important that how the engine functions and how the gear rod functions. These functionalities are not important for us, being an end users or customers. So abstraction is also there in car or 2-wheeler. In the same way, it is there for aircrafts, and it is there for mobile phones, and it is there for your computers, laptops, etc. things. I can say that there is no mechanical or electronic product without a feature called as abstraction. Abstraction is already there since from many years. Alright, how exactly the abstraction is important for other products? In the same way, the abstraction is very important for software product. That's it. So there are so many programming languages which will not guarantee abstraction, but Java guarantees abstraction. Now I'll tell you formally what is abstraction. Abstraction is the process of hiding unnecessary details and displaying only necessary details, or allowing user to use only the necessary operations. I'll tell you some examples relating to software products where the abstraction is applied. Google search. While using Google search, you know, the Google search is a very big search engine in the world. Using that Google search is quite easy. one need not to be an expert from computer science to use Google search. Anybody can use Google search. But in order to develop such kind of search engine, what kind of algorithms are used, which programming language is used, and how much memory it takes, and how much data has to be stored, these internal details are hidden. It's a best example. Google search is a best example where abstraction is at higher level. In the same way, we have an applications like Amazon and eBay, Facebook, WhatsApp. All these applications are achieved using a feature called as abstraction. It means that they should have developed using object-oriented programming languages like Java. Now we'll see what is encapsulation. Every program has an operation. For an example, operation of addition of two numbers, three numbers, or finding factorial of a given number, etc. things. Those are operations. To perform an operation, data is required. Right? So in a program, there are two things. One is data and other is operation. More formally, one is data variable. Data is stored in data variables and operations are kept in the functions or methods. Two things. Every software program has two things in common: data variables and member functions, also called as methods. And the operation is coded inside these functions or methods. Good. Now, there are some programming languages which will keep these two things independently. That means the data variables separately and memory functions separately. And there are some programming languages which will combine these two, data variables and member functions, together. Now, the important point is that which one is good one? The good one is to combine data variables and member functions. By combining data variables and member functions together, wrapping them together, that will allow us to do very nice programs, very good programs, and we can achieve reusability and many features. We can achieve this thing using a feature called as encapsulation. Now coming to the formal definition of encapsulation. It is the process of combining data variables and member functions. In other words, wrapping data variables and member functions together. In Java, we achieve encapsulation using class. Class is a combination of data variables and member functions. In whatever the programming languages, if there is no class, means there is no encapsulation. By the way, how do we achieve abstraction means? We achieve abstraction using an object and we achieve encapsulation using class. These 2 points are very, very important, most widely asked questions during your software interviews. Now we will see what is inheritance. Inheritance is the process of acquiring properties from one class to another class. So whatever the labels that you are seeing in this view, A, B, C, in these three diagrams, simple inheritance, multi-level inheritance, hierarchical inheritance, A, B, C are classes. There are three types of inheritances: simple, multi-level, hierarchical. We'll see one by one with example. A is a class, B is a class. B is acquiring properties from A. It means that in simple words, A is a parent class, B is child class. Child is getting properties from A. What is the importance? Why it has to get? Means, for an example, A has some functions or so much data. B wants to use the data and the operations of A. In such case, inheritance will help us. Okay, so inheritance is a beautiful concept which will drastically reduce the amount of development time in the software development life cycle. If inheritance is used, we can create projects in very short time, rather compared to where we don't use inheritance. More formally, A is called as base class. I repeat, A is called as base class. B is called as derived class. Derived class acquires properties from base class. Basically, any class will have what kind of properties? Not televisions, microphones. A class will have properties like, tell me, like I have already told you, like data variables and member functions. So these data variables and member functions a child class can acquire, allowing that child can directly use them without rewriting the same code and without retaking the same kind of data. This is the advantage. So this is simple inheritance where you have one single parent class, one single child class. Coming to the multi-level inheritance, here B is acquiring properties from A, C is acquiring properties from B. Indirectly, C also acquires properties from A. It is a relationship between grandfather, father, and son. I hope you understand the point. This is hierarchical inheritance. So many times we'll be using this inheritance a lot. And here you have one single base class, and there are so many child classes. So more than one child class acquiring properties from one single base class. This kind of inheritance is called as hierarchical inheritance. So basically you will have one single base class, multiple derived classes acquires properties from a single base class. Right. So Java supports these three types of inheritances. The programs and furthermore examples relating to inheritance will be seeing in the upcoming lessons. Now we'll see what is polymorphism. The meaning of polymorphism means having more than one form. So one of the important features in Java. In non-oops programming languages like C or Fortran, abstraction, encapsulation, polymorphism, inheritance, these four features are not there. Since they are lacking of oops concepts, we cannot develop very efficient products in very short time using just by C language or by using Fortran language. Programming languages like Java supports this kind of features like polymorphism, abstraction, encapsulation. In polymorphism, you will better understand using that diagram having more than one form. A person is having more than one form. A person can be a father, a person can be a husband, a person can be an employee. And the roles and responsibilities of a person being a father is different from the roles and responsibilities of a father being husband and being an employee. These are the different roles. These are different roles. But all these different roles belongs to one single person. You will better understand the implementation of polymorphism in the upcoming classes. As part of this lesson, you should just simply understand polymorphism is having more than one form. There are two types of polymorphisms. One is compile time polymorphism and other is runtime polymorphism. We achieve compile time polymorphism using a concept called as method overloading, and we achieve runtime polymorphism using a concept called as method overriding. Whenever you are appearing any interview for Java, you see, I am pretty much sure that 100% I am sure that there will be a question on method overloading or method overriding. They'll ask you the difference between method overloading and method overriding. And as part of this lesson, you understood only one simple point, that method overloading and overriding are related to polymorphisms. Method overloading is related to compile time polymorphism and method overriding is related to runtime polymorphism. Apart from these things, you will not be knowing much more details as part of this lesson, but we are going to see very beautiful programs and with very beautiful examples in the upcoming lessons. I'll concentrate a lot on polymorphism. So what is polymorphism? Having more than one form. And how many types are there? Compile time and runtime. We achieve compile time polymorphism using which concept? Method overloading. And we achieve runtime polymorphism using which concept? Method overriding. We are done with the oops concepts in Java. Now we will see some other important features, equally important features like oops concepts. These are, Python is also an oops programming language, and C++ is also an oops programming language where abstraction, encapsulation, inheritance, polymorphisms are common. But there are some other features that are uncommon. These important features that I am going to discuss are inbuilt features of Java. These are not under oops concepts, but very important features of Java. So I'm displaying you here three important features of Java: platform independent, garbage collection, exception handling. We'll see what is platform independent means. Whenever you write a Java program, you might be knowing that every program that is written by you has to be compiled first, and then you have to execute. Then only you can see the result. So what is compilation? During compilation, the syntax errors will be checked. That means whether you have followed the grammar correctly or not will be checked by the compiler. Once after everything is correct, it generates a bytecode, also called as an executable binary. You might be knowing that computers can understand only zeros and ones in order to execute a program. So in order to execute a Java program that is written in English has to be converted to binary language. This job is done by a compiler. The bytecode that is created by the compiler is platform independent. It means that a bytecode that is generated in Windows operating system can be executed in Unix operating system. Okay, how beautiful it is. It's so simple. Bytecode is very easy to carry, compile anywhere and execute anywhere. Okay, platform independent feature is there in Java. And in the same way, the second feature, garbage collection, very important feature and very powerful feature, garbage collection. Look at here, I already told you what is an object. Object is an instance of a class. I told you that for a class, you can create any number of objects. Let us imagine for a huge or a big application, you may be creating some thousands of objects. And objects occupy memory in your RAM, random access memory, in physical memory. It occupies, because an object holds the data is stored in the memory. And being a programmer, we need to clear that memory based on unwanted objects. We need to identify the unwanted objects and we need to delete them. Just like whenever your memory is full in your mobile phone, how do you recycle that one? You may be deleting unnecessary files. In the same way, in order to reuse the memory effectively, you need to delete an unwanted object. It is one of the biggest hectic job for a programmer, but it is not such a big deal for a developer who is working on Java, because Java has a beautiful feature called as garbage collection. Java is very intelligent programming language. It automatically knows which object is unwanted. An intelligent algorithms are there inside Java compiler and executable itself. They'll automatically identify the objects that are no longer in use. Automatically those objects are deallocated. That means deleted, removed in simple words. They're removed, and whatever the memory that is occupied by those number of objects will be regained, so that you can reuse the memory for the other purposes, making your system more flexible. So a programmer need not to deallocate the memory. Java automatically deallocates the memory. This is the concept called as garbage collection, one of the powerful features of Java. The third feature, exception handling. You know, many people say that Java is a robust programming language because it is side effect free. It is side effect free and error free because it has powerful exception handling, an inbuilt exception handling feature. Very great feature. Exception means bug, an error, or a problem. Okay, so we can fix our problems using a great exception handling features that are available already in Java. Using all those exception handling features, we can fix the bugs within our code. That's it.